Hi, this is Umesh Horegata. I'm the Chief Technology Officer of New Sigma Analytics Lab, where we specialize machine learning, natural language processing, and AI projects and services. Today, I'm going to talk about the questions that I received during the data visualization summit. There I gave a talk on machine learning patterns and data visualization. So we had an excellent session, and there were a number of questions during the session, and I just thought of creating a video to answer those questions. I could answer some of them during the session, but I decided to create a video to make sure I answer all those questions in today's video. These are the list of questions that I received during the session. The questions are as follows. What technical skills a data scientist would need? And then what Python libraries are useful for data visualization? Is it always necessary to visualize the data? How do you decide which data visualization technique to use for a given data set? Then what are the different types of data analytics we have? And then what do you need to do to become a good machine learning specialist or a data scientist, and how do you keep up with these fast growing technology? So let's try to answer each question one by one. It's a long session. It's going to take about 10 to 15 minutes, particularly the question number 4, that is how do you decide which data visualization techniques to use for a given data set. I'm going to explain each of the different techniques we have and when to use which techniques. So that question is going to take a little bit longer, whereas all the other questions are pretty straightforward. So let's begin with answering these questions. The first question is what technical skills a data scientist would need? This question is asked by Fatima. Data analyst, you have to understand the statistics, the fundamentals of data mining and different machine learning algorithms, supervised machine learning, unsupervised machine learning, all these different techniques, clustering, classification, regression, neural networks, deep learning. So this knowledge is very important. Then you also have to know how to access the data. How do we get the data from a database and maybe writing SQL queries? How do you read the JSON files? All these things are very important, including accessing the big data files like HDF5, NoSQL, understanding of MongoDB, Cassandra. So these things really help in order to fetch the data or get the data from different places. Of course, you got to have a good programming skills, Python, R, or Java, to write the machine learning applications and how to go about solving machine learning problems. And having a good understanding of some of the tools such as Microsoft Azure, IBM Watson, SPSS, Weka, or any other machine library would definitely help. Is the communication skill. More details, I have created a video on the tools, specifically what are the data science tools. That video is available on the YouTube, and you are free to watch that. The next question, what Python libraries are useful for data visualization? This question is asked by Madhukar and Fatima. This is just the important libraries that are available on Python, specifically for data visualization. NumPy and scikit. You have matplotlib, which it's the oldest and it resembles the MATLAB libraries. Pandas, mainly for data analysis and modeling. Then you have ggplot. Basically, it is from the R, but it is also, there are wrappers for Python. It's called the grammar of graphics. Very good graphics you can create using ggplot. Similarly, you have something called Seaborn, which uses the MATLAB libraries to create beautiful charts in very few lines of codes. And then you have something called Bokeh, create your web-ready plots. The output of this could be a JSON object or HTML document or interactive web application. Then you have Plot.ly. Mainly it is known for its online visualization tool, but it also has offline libraries available, and it is popular for contour plots, dendrograms, and 3D charts. So you can use geoplotlib to create maps. Then similarly, you have NetworkX for network graphs. The third question, is it always necessary to visualize the data? This question is asked by Jonathan Walker. The answer is yes, mostly yes, except where the data volume is very less, say less than 100 records, and variables are limited. And mainly the business problem is very straightforward. For example, which store sells the highest, or who is the best salesperson. It is just one single number. By looking at the records, you will be able to pinpoint, okay, this is the highest sales number, or this is the highest income, for example. So where the volume is limited, the variables are limited, the business problem is straightforward, you don't have to really do any visualization. You can just look at the data and you should be able to say. Otherwise, yes, it definitely helps. Then what are the different types of data analytics? This question by Philip. Well, typically, if you want to classify these analytics based on the functional areas, I would classify under these following categories. For example, marketing and sales analytics, which involves marketing product in different segments, or sales performance, sales regions. Now these are different analytics you can do, how your product is performing in different regions, for example. Similarly, related to the HR function, I call it as HR analytics, basically about the functions of HR, such as performance, retention, compensation, or new job skills that are require new job skill acquisition, if you want to call it as. These are some of the HR functions, so you can call it as HR analytics. Similarly, you have operational analytics related to the manufacturing, understanding the performance of your plant, maybe your machinery or line performance, maybe quality performance or improvement of your product quality, and operational planning and efficiency. So these are some of the operational related analytics you can perform if you have enough data. Similarly, you can perform analytics related to your systems and your security. Now, for example, understanding the events on your system, event monitoring, maybe network performance, your access performance, or different kind of applications that you have on your system, how exactly your applications are performing. You can also do security analytics, such as your fraud analytics, compliance analysis, etc. So broadly, these are the types of different analytics that you can perform depending on the functions. Then the next question is, how do you decide which data visualization technique to use for a given data set? So let us see what are the different types of data analytics techniques we have, and how we can use different techniques to solve different types of problems. So the technique depends on the type of problems to be solved and the dimensions of the data, or the number of parameters that you have in the data. There are a number of techniques such as line chart, you have bar chart, pie chart, box plots, histograms, contour plots. There are many techniques are available, but which techniques to use when? And that is the question. Again, we are going to look at each one of them and then see how it is used in different types of problems. Bar chart basically is used for comparison. Simple bar charts are used for plotting mode or median or any statistic that you want to find out, or even a percentage, for example. So there are two types of bar charts. One is vertical bars. If there are less number of variables or less number of bars, you can use vertical bars. Similarly, horizontal bars, you have a number of variables more to compare, then you can use horizontal bars. Typically, if you have less number of bars, then you go with the vertical bars, and if you have more number of variables, then you go with the horizontal bar. The stacked bar chart is an extension of a bar chart where another dimension is added. The sales quantum of different products are stacked together for different brands across different regions, so which we discussed in our last session. Histograms typically used for understanding the distribution. It is a frequency distribution over a specified discrete intervals. Histograms gives us whether the data that you have is normally distributed or binomial distribution or any other distribution. So that helps in understanding the distribution of the data. So in this example, sales of online store over 4 hours range is plotted, and this is how the histogram looks like. It is more or less, it is normally distributed in this particular example. And pie chart is used for depicting percentage of distribution of any particular aspect over different groups or intervals or ranges. For example, I just have said P1, P2, P3. So you have maximum 32%, and the next one is 26%. So it is easy to understand using this pie chart how exactly the performance is based on the percentage. A network graphs is used to depict your connections with your different groups in your social media such as LinkedIn or Facebook. It helps to understand your network, how you are connected basically. Contour maps, in order to depict the concentration of a particular aspect, the contour graphs or maps are used. So in this example, I tried to find out the purchase and income, and then how it is distributed online versus in store. Okay, so this just gives you the concentration of your purchase. Scatter plots basically used to understand the relationship between the two variables. So in this case, revenue versus number of employees, we try to understand the relationship, and then that also gives you kind of a trend, or what kind of relationship. Is it a linear relationship or it's a non-linear relationship? So it just gives you an idea how these two variables are related to each other. Similarly, you have line charts, basically used for progression of data over a period of time and also to do trend analysis. So this is an example how different brands are performing over a period of 24 hours, the sales performance. And the Boxplot basically again is used for a comparison of various parameters, median, maximum, minimum, quartile, basically a statistical summary. It gives you a very good statistical summary, what we call it as 5-number summary. It is used for again comparison of various parameters. This is the last question. What do you need to know to become a good machine learning specialist, data scientist, and how do you keep up with this fast growing technology? This question is asked by William. Just to give you an idea, as a scientist, you have to understand the research methodologies. I call it as, how do you conduct a research, how do you solve a problem, and what are the various machine learning algorithms that are there, and how do you apply each of these algorithms, and when do you apply these algorithms, and have to have an understanding the constraints and limitation of each algorithm. The main important aspect of a scientist is to understand or analyze the output given by the model, right? And how do I read the output? It throws mathematical numbers. What is that number? Is it statistically significant, right? What is p-value, for example, right? How do I improve the model performance? What are the ways in which I can improve the model? Maybe developing new algorithms, right? So this is very important for a machine learning specialist or a data scientist. It is truly a science. You have to use all the methodologies that you have learned while you conduct your science experiments or physics experiments, right? The same thing that applies for conducting your research or solving a problem using the data. So I hope this has answered your question. If you find this beneficial, please share it with others so that others can also learn and benefit from this video. Thank you very much. If you have any questions, please contact me on this number or email, right? And also you follow me on Facebook and Twitter or LinkedIn so that you will be up to date with the technology. Thank you very much.